To go?
Yes, yep. Thank you. Yes.
Cool. Yep. So hi everyone. I'm Tom Gowland, and I'm just going to talk about the models and workflows on DAFNI. So Bethan's introduced you to the data section. So if I go and click into models, you can see a list of all the models that we've got on the platform. These tend to be made up of the pilots that we've done in the past, but also we've more recently had some user engagement and people trying out uploading their own models to DAFNI, which has been pretty cool. But the main thing I want to show you today is how you go about adding a model, the stuff that you need to do to be able to do that. So I'm going to add a model. And the model I've chosen to demonstrate is the COVID-19 sim from Imperial College London. I think that kind of demonstrates the use case of DAFNI pretty well, because it's a really computational heavy model. So it takes like 30 gigabytes of RAM to run it for the whole of the UK, which typically you wouldn't have on a desktop machine. It's quite complicated for a non-technical user to go in and actually be able to run it successfully. So if someone packaged that up and then put it onto DAFNI, it makes it easier for a non-technical user to come along and then run that. So we have extensive documentation to show how to actually go about doing that, but essentially you need these two files, one of which is a model definition YAML file, and that's all of the metadata associated with your model. So the name, the description, stuff about the inputs and outputs, and we'll come back to that in a minute. But there's also this zipped up model image, which essentially is a Docker image. So you've put all your code into this thing called a Docker container, which is just a way to package up your code to make sure it runs the same wherever you run it. And then you essentially just zip that image file up, and you can then upload that onto DAFNI, and we'll unzip it on our end. And the whole idea is that the packaged up code will run the exact same way on your machine as it does on DAFNI, so you can make sure that you're still getting the same outputs and that kind of thing. So I've done that ahead of time, obviously, and then you just click add model, and those files will then upload, but we're not going to wait for that to finish. But here's one I did earlier. It's just the exact same stuff that I've just uploaded now, but obviously the upload process is finished. And you can go onto your model page, you can see all of the metadata that you included in your metadata file, including some parameters. So you've got minimum and maximums, what kind of type they are. And then you also get this list of output files. So you can see that we're expecting a load of Excel files to come out of this model that show us a variety of different stats about your COVID simulation. So now we've got the model on the platform, we just have to run it using our workflow system. So this is kind of the meat of the platform, really, and this is where you actually come to run these models. So you can see a load of workflows that have been created over here and a load of workflows that have actually run down here. But if I go into create a workflow, and I'll just put in some random stuff into this, I'm then taking this to this page. So this is where you can actually start to build up your workflow. So in here we have multiple different step types. I'm not going to use them all today, but we have an iterator step type, which will essentially iterate over the same step in your workflow multiple times. And we have this iteration technique called Monte Carlo, which will essentially vary a certain parameter on that model between a given minimum and maximum. And all of those model runs happen in parallel, so you can get results at the end and do some kind of sensitivity analysis on that. The next step type that we have is the actual model step types. This is actually where you put in your model into the workflow to actually run your simulation in the background. So we will actually do that for the COVID model. So we come back into this model list, we can select our model from earlier, and we can see the metadata again just to make sure we've got the right one, and then we press select. And then down here, this parameters table gets populated with the parameters that we've specified in our metadata file, and then we can choose from a list of options for the country. We can change the R number to be whatever we want, and then you can change other things like household level of compliance, or how long people have to isolate for if they show symptoms. So now we've created that step, we could then go in, and in theory we could make another model step. So in a kind of system of systems approach, you would then put in another model step. So one project that we're working on that Tom talked about is NISMOD, and that is a huge system of systems model. So I think later in the year we're doing a NISMOD demonstration of how we can do this system of systems modeling on DAFNI, and that'll have multiple model steps chained together. But we're not going to do that today. We're going to go straight into publishing some results out of our COVID-19 run. So obviously there's some data that comes out of this, and there's a couple of things that we might want to do with that data. We might want to just publish it into the data catalog that Bethan showed you earlier. And so there we have to fill out the same metadata form that Bethan showed, and that would essentially just put your data set straight into the NID, and then you could share that with other users later on. The step that we are going to add is visualizations. So we can go a step further than just outputting it into the data catalog. We can actually spin up some kind of visualization on that. And so at the minute, we only have one type of visualization, which is Jupyter Notebooks, which I'll show you in a minute. But we're actually currently working on a web tool that can support drag and drop visualizations, essentially. So we're hoping to give something for non-technical users to be able to use our visualization features as well. We still have to fill in the metadata for this, just because the data set still gets outputted into the data catalog before it gets loaded into the visualization itself. But I won't bother filling in all of this stuff because Bethan has already shown you all that. But the final step is just to say which files from our model run that we want to actually output into our visualization. And so then you would put in the path to those files, which in this case is /data/outputs. And then you would create that step in the bottom right, and that would create you a visualization step. But again, for time's sake, that I've sort of created one before, which is this one. So it is a completed workflow. So I've done almost exactly the same as what I've just shown you there, apart from I actually filled in the metadata for the visualization. I ran it through. It took about half an hour to complete for the whole of the UK. On a desktop machine, it probably would take a lot longer if you actually had the hardware resource to be able to run it in the first place. But now we've got our Jupyter notebooks, so we can click visualize in there. Oh, I've already got it open, so I'll just find it. And essentially what I've done here is, so a Jupyter notebook essentially just facilitates users to be able to write some code to do some post-processing on their data, but also whilst making use of the high performance compute behind the scenes on DAFNI. So this is a Jupyter notebook that is running on DAFNI that the user can access through their browser, and then they can write some code. This code is just all borrowed from the Imperial College London GitHub page, which does some visualization on the outputs. So you can see our Excel files have come through that we saw were going to come through earlier, but they're kind of like, well, it's difficult to figure out what's going on if you're just scrolling through. So you could write some code to draw some graphs, essentially, is the idea. And so then I run that script and it generates these plots, and you can actually see some meaningful statistics about what your simulation has shown, essentially. And like I say, obviously, one of the main ideas of DAFNI is to take this technical model and make it available to non-technical users. So this kind of is not great for technical users because they still have to write some code, but we are working on a visualization tool which would be much more applicable to non-technical users to be able to draw graphs of their outputs as well. But yeah, that was all I had to say, really.